So in this video, we're going to look at acids and bases, and we're specifically going to look at conjugate acid-base pairs and neutralization. And our learning intentions are to explore conjugate acid-base pairs. We'll do some examples and some exam questions. We're going to explain how neutralization of an acid and base gives a salt and water, and we're going to give 2 everyday examples of neutralization. So next we're going to look at conjugate acid-base pairs, and conjugate acid-base pairs can be identified by a reversible reaction, and a reversible reaction has this symbol in the middle, so it's a 2-sided arrow, and you'll meet this symbol in the equilibrium videos. So what we're going to do is we're going to look at an example, and we're going to see conjugate acid-base pairs in action. So if we look at the reaction that we have here, we've got NH4 plus water going to ammonia plus the hydronium ion. So if we look at the forward reaction to start with, we can see that the NH4 plus is converted to NH3. So the NH4 plus has donated a proton. So if it has donated a proton, it is acting as an acid. So we say the NH4 is an acid, so the NH3 must be the conjugate base. And we know this because if we go backwards, we can see that NH3 goes to NH4 plus, so it is accepting protons in the backwards reaction, so that would mean it is a conjugate base. If we look at the forward reaction then, we can see that our water turns into a hydronium ion, so it has accepted a proton. So in the forward reaction, water is acting as a base because it has accepted protons in the forward reaction because we've gone from water to the hydronium ion. So we say that water is a base, but we can say that the hydronium ion is a conjugate acid because if we were to work backwards, we can see that the H3O plus, the hydronium ion, turns into water. So it will have lost a proton, meaning it has donated it. So it is a conjugate acid. So if I was to label this forward reaction now, I would say that the NH4 is an acid, and I would say that the NH3 is the conjugate base, and I would say that the water is a base, and that the hydronium ion H3O plus is the conjugate acid. And these are the pairs because the water accepts a proton to become H3O plus, the hydronium ion, so the base links up to the conjugate acid, and the NH4 plus converts into ammonia, so we know that the NH4 plus is an acid because it gives NH3, so it has donated a proton to give the conjugate base. So to summarize that example that we've done there, an acid changes into its conjugate base when it donates a proton. And in our last slide, the NH4 plus ion was the acid because it turned into NH3, which is ammonia, indicating that it had donated a proton. A base changes into its conjugate acid when it accepts a proton. And in our last example, H2O was the base because it accepted a proton in the forward reaction to become H3O plus, which is the hydronium ion. And the most important definition, a conjugate acid-base pair is any pair consisting of an acid and a base that differ by a proton. So in our previous example, we had NH3 and NH4 being a conjugate acid-base pair. And we also had water, which is H2O, and the hydronium ion being a conjugate acid-base pair. So let's look at a sample exam question here. It says, explain by giving a balanced equation for its dissociation in water that the conjugate base of sulfuric acid is itself an acid. So if we're to look at this, the conjugate base of sulfuric acid is HSO4 minus, and we know that because sulfuric acid is H2SO4, And we know that if something acts as an acid, it becomes the conjugate base. So if it's acting as an acid, it's going to lose a proton to become HSO4 minus. So the balanced equation for the dissociation of the conjugate base of sulfuric acid in water is as follows. You've got HSO4 minus, which is the conjugate base of sulfuric acid, reacting with water. And what that forms is the water. We want to show that the conjugate base of sulfuric acid is an acid itself. So we want to show that this HSO4 minus is acting as an acid. So if it is acting as an acid, it will lose a proton. And we can see that that does happen as the HSO4 minus becomes SO4 2 minus. So that means that the HSO4 minus conjugate base of sulfuric acid is an acid itself, because it causes the water H2O to become a hydronium ion. So the water is accepting a proton, so the water must be acting as a base. So the HSO4 minus ion donates a proton to the water molecule, so that means the HSO4 is acting as an acid. So that answers the question that the conjugate base is acting as an acid. Here's another sample question that usually comes up. We want you to write the conjugate acid and the conjugate base of HPO42 minus. So a conjugate acid is always formed from a base. So if you want to find the conjugate acid of HPO42 minus, you must assume that it is acting as a base. So a base is a proton acceptor. So this HPO42 minus will accept a proton to become H2PO4 minus. And that is our conjugate acid. Next, we want to find the conjugate base of HPO4, and a conjugate base is always formed from an acid, and an acid is a hydrogen ion donor or a proton donor. So that means that the HPO42 minus will donate a proton or lose a proton to become PO4 3 minus, which is the conjugate base. So these examples do take a little bit of thinking. You do have to write things down and take a second to digest what the question is asking before you answer them. So let's just look at another style of example that could come up. It says, in the following equation, indicate the acid base and the conjugate acid base pairs present. And here's your balanced equation. So let's give it a go. If we take a look at our H2SO4, we can see that it becomes HSO4 minus in our product side. So that means that the H2SO4 is a proton donor, so it is an acid. Similarly, if we look at the HF goes to H2F in your product side, so that must mean that the HF is acting as a base because it accepts a proton to become H2F. Now, we always say that an acid becomes the conjugate base, so that must mean if H2SO4 is an acid, it means that HSO4 minus is the conjugate base. And if HF is the base, it must mean that H2F is your conjugate acid. Now, let's check that. If we were to do this as the backward reaction, does this hold? So we can see that H2F in the backward reaction would be acting as an acid. So that would mean that the HF would be the conjugate base, because if H2F is an acid in the backwards reaction, it is donating a proton. So it would lose a proton to form HF, which we can see is correct. And then we've got HSO4 minus. We've said that it's the conjugate base. So if we were going backwards, it would act as a base. And we know that a base is a proton acceptor. So it would form the H2SO4, meaning that the H2SO4 would be a conjugate acid. So these pairs are correct. In the forward reaction specifically, the H2SO4 becomes HSO4 minus, so it is an acid becoming a conjugate base, and the HF is a base going to H2F, which is the conjugate acid. The last thing we're going to touch on is we're going to touch on neutralization. So a neutralization reaction is when an acid and base react to give salt and water. And this is very common from junior cycle. So the definition for a salt is a substance formed when a hydrogen ion from an acid is replaced by a metal or an ammonium ion. So as you can see here, the hydrogen ion of our acid is replaced by the metal ion from our sodium hydroxide. Everyday examples of neutralization. This can come up in question 4. Give an example of how the lime goes through the process to neutralize this acidity in the soil. The second everyday example of neutralization is medicine, and that's mainly sodium hydrogen carbonate is used in indigestion tablets to neutralize excess acid in the stomach. So that comes from the likes of Gaviscon. Gaviscon has a sodium hydrogen carbonate active component in it that neutralizes the acid in your stomach to form sodium, chloride, water and carbon dioxide. And you can clearly see here that the hydrogen ion in your acid has been replaced by a metal ion. So that's it for this video. Have a look over the learning intentions to make sure you understand everything we've gone through.